So the purpose of this activity here is so that you can explore more about numerical exponents and bases. So we're going to take a break from variables or letters, and we're going to explore more with numbers. So what we have in this table, on this side, these values, I should have gone all the way to the 10. Let me draw a bracket. So all of these numbers here, these are bases. My pen's giving me a hard time. So these are bases. We have a base of 1, 2, 3, 4, and so on. The numbers on the side represent the exponents. I don't know why I tried the squiggle again. Let me just draw the bracket. So these are the exponents. So a couple of these are already completed for you. So in this first box here, 1 to the first power is 1. The base of 2 to the first power is 2. A base of 3 to the first power would be 3, and so on. So if you notice, if the exponent is 1, the number is always going to be itself. So anything to the first power is itself. The next exponent is a 2. So 1 to the second power means 1 times 1. This is 1. 2 to the second power, or 2 times 2, is 4. 3 to the second power, or 3 times 3. Oh, sorry, I'm looking at the next base. It's okay. Sometimes it can get a little confusing. Oh, no, I was correct. See, I was looking at the exponent and not the base. 3 to the second power is 3 times 3, which is 9. 4 to the second power, or 4 times 4, is 16. 5 to the second power, 5 times 5 is 25. 6 times 6, so you don't have to keep writing it out in exponent form if you get used to it. You could just do 6 times 6, which is 36. 7 times 7 is 49. 8 times 8 is 64. 9 times 9 is 81. And 10 times 10, or 10 to the second power, is 100. So you might start to notice some patterns going down the rows here. So if you look at the first column, if we have 1 raised to any power, 1 raised to the third, 1 raised to the fourth, it's always going to result in 1. If the base is 2, 2 to the first is 2, 2 to the second is 4, 2 to the third is 8, what do you notice keeps happening to the next number? If you notice, it keeps doubling. So 2 times 2 is 4, times another 2 is 8, times another 2 is 16, times another 2 is 32, and so on. The same thing's going to happen with the 3s. 3 to the third, which is 3 times 3 times 3, is 27. So everything in this column is getting tripled 3 times. 3 times 3 is 9. 9 times another 3 is 27. 27 times another 3 is 81. Okay, so to find the next value, 81 times another 3 is 243. 243 times another 3 is 729. So I'll put this in green if anybody wants to notice. So times, too thick. Back up. So times another, why did I put a plus sign? Times 3 again. You don't have to write this. This is just for you to visualize. Times another 3 gets us the next number. Times another 3 gets us the next number. So each time the exponent increases once more, you multiply by an extra base. So times another 3 is 2,187. Times another 3 is 6,561. So I want you guys to explore the rest of your table on your own. So use the patterns to fill in the rest of the table over here. Okay. This is an exploration lesson. This is for you to explore more about the bases and the exponents and how they affect the final answer. So over here in this table, you're explaining the patterns, and I already shared out some of them for the 1, the 2, and the 3. So in example 2 to the x column, I notice that the numbers are doubling each time, right? So doubling means times 2. So we have 2, 4, then 8, then 16. So everything here, what is happening? Everything here all right. It's okay. I'll get it. So it's not always going to be perfect, but that's okay. I know you guys are being patient with me. Okay. You know what it is? I keep putting my wrist. I'm using a tablet to record the video. And it's a new tablet, so I'm not used to it just yet. Okay. So if we multiply by 2, we get the next number. If we multiply by 2, we get the next number. Everything keeps doubling. So anytime the base is 2, so 2 to the first, 2 to the second, 2 to the third, we get all of these values. Okay, and this is the word form. If we double 2, we get 4. If we double 4, we get 8, and so on. So in 3 to the x column, we notice, you can say I notice, the numbers triple. The numbers triple each time. So 3 to the first power was 3. 3 to the second power was 9. 3 to the third was 27. 3 to the fourth was 81, and so on. So if we triple 3, you get 9. If we triple 9, you get 27, and so on, right? So if we put dot, 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 that means the pattern continues. So for the rest of the table, pick any values from the column. You can go to the 5, the 6, the 10, right? This is actually a really interesting one, the one with the 10. That's going to tie in with the second half of this unit. So I would definitely recommend exploring what happens with the values of 10 as the exponent increases on that base. Explore C. I'm going to write the word challenge here because this is a little tricky. This is going to be taught in a future handout. You'll notice sometimes we have negative exponents. And when we have negative exponents, they give us a special type of number. So this here, if you work backwards on this same table, so imagine if we were going backwards on the table, right? We would have a 0, a -1, a -2, and so on. So that's what this represents. So if we have 0 to the first power, let me write it so that we remember. These are our exponents. And these values here are the base. So these were all the bases that we had here. So if I take 3 and raise it to the 0 power. If you type this into your calculator, you're going to get 1. 4 to the 0 power, you're going to see the result again is 1. So anytime the exponent is 0, the final answer is going to end up being 1. When our exponent is -1, so let's test it out. 3 to the -1. If you type this into your calculator, it's going to give you a decimal. It's going to give you 0.333 repeating. If you change it to fraction mode on your calculator, you'll see it gives you 1/3. 3 to the -2nd power, if you type this in fraction mode on your calculator, is 1/9. Sorry guys, I went the wrong way. I should have put that here because our exponent is -2. Would be 1/9. So let's see what happens with the base of 4. When the base is 4 and the exponent is -1, this is 1/4. When the base is 4 and the exponent is -2, this is 1/16. I'll do one more, see if you guys notice a pattern. 5 to the -1, when the base is 5, the exponent is -1, this is 1/5. 5 to the -2 is 1/25. So see if you can fill in the rest of the table here using that pattern. Okay, and this is a challenge part, so do your best. Do your best. This is an exploration because we're going to learn these rules in a future page of the packet. So do your best to answer the questions that follow on this handout. So finish Explore B. And remember, I mentioned Explore C is a challenge.